All right, everybody, we're going to go ahead and get started. Thank you all for coming. This is the Google Developer Group. We do this every third Thursday right here, so come back and talk to us. This month, obviously, we're talking about Flutter. Next month, we're going to skip our regular meeting because we're going to be running a tech conference down in Cincinnati called Ohio Dev Fest. Yeah, so come out. Tickets are still available for that. It's going to be a good time. It's an all-day conference. We're going to have 4 tracks, 30 speakers, an after party at Rheingeist Brewery. So come on out. It's going to be a really good time. And then in November, we're actually going to be teaming up with the GDG Android group here in Columbus to run the Flutter Study Jam. So if you want to go through the Udacity course to learn how to do Flutter, join us for that. And it's going to be a 3-parter. So it's going to be 3 weeks in a row where we're going to go through that Udacity course. And then we're going to wrap up the year with the Tech Columbus Christmas party. Cool. So now I'm going to hand it over to Andrew, who is from the Flutter team out at Google, who's been kind enough to come talk to us.
Thanks. Thank you. So my name is Andrew Brogdon. I'm an engineer on the developer relations team for Flutter at Google. Before that, I was on the mobile ads team working for AdMob, also in developer relations. Some of you, I think, have mentioned that you might have seen me in some YouTube videos that I do for Flutter and mobile ads. Fun fact for you guys, I am much worse live. So that's something we all get to enjoy. I'm not actually an experienced speaker. I go on camera. I don't do this stuff live. But I have, I think, 141 slides. Not kidding. And I haven't really rehearsed this, so it could go 20 minutes. It could go 6 hours. So just make your way out in your own time, if you get bored. But I just want to say thank you to Casey and Pete and everybody here who came and is working on this for helping me trick Google into paying for me to come to Columbus. I live in San Jose. I work in sort of the Google mothership in Mountain View. But before that, I lived here in Columbus for about 6 years. I have a degree from Ohio State U, or the Ohio State University, probably like most of you, in poetry. And I would move back here in a heartbeat if I could take my job with me. So thank you. But I transferred on the Flutter team in April. And so I had to make a certain amount of adjustment to get to know Flutter and get comfortable with it. And that's what this talk is about, as I keep elbowing the screen. There's a point, I think, where you get comfortable with something that you're working with. Like you first start out, you read the docs, you go on Stack Overflow, and you sort of like you piece together code that other people have written, and you do that for a while. And then you get to the part where if it's something you've already seen an example for, you can add to it or modify it. And then later you get to a point where you sort of know how all the pieces fit together and move, even the code that you didn't write. Like the stuff that's in the engine, under the hood, you can picture it in your head. And so that's a smart way to do this, that's an inefficient way to do this. You know what I mean? And so that's what this is about, how I got from being a noob who didn't know anything to a state where I'm at least comfortable now coding with Flutter and working in Dart. And specifically looking at the way widgets work and building an app. So when I first started, I was coming from the AdMob team, and I was working on let me see if I can do this right, an app. Let me copy my speaker notes here. Like I said, inexperienced, giving talks. I figured this is a friendly crowd. So I had an app that looked kind of like this. It had a list of buttons, and I wanted to turn a button on and off based on some Boolean that I had, whether an ad was loaded, because this is an example for the AdMob plugin. And so I came down here to the button. Can everybody see this, by the way? I'm assuming everybody can. Is this big enough? Okay. And I started to type out enabled because I wanted to turn it off, and I got the angry red squiggle, and I was like, what on earth are you talking about? I've got to be able to turn a button on and off. And so great thing about Flutter, completely open source, everything, the tools, the SDK, everything. So you can drill down into any class, none of it's hidden from you. And so I'm like, all right, there's got to be an enabled property in here. So I go looking for it, and it says, to enable a button, set its onPress property to a non-null value. And so it has enabled, but it's a getter, it's not a setter. So the only way you can set this is by setting a function to a value or setting it to null. And I was like, how the hell do you toggle it then? I don't want to have to tear down a function and then rebuild. What if it's a closure? It's got other state in it, all sorts of stuff. This is sort of nuts. And so that led me to this question: why doesn't Flutter have a setter for enable. One of the great things about my job is that I work 20 feet from the SDK team. But before I go talk to them, I tried to go through the source. And I came upon this line: a widget is an immutable description for part of a user interface. I was like, okay, that sounds, I don't know what this immutable thing is all about, but that sounds okay. I can live with that. I kept reading. A given widget can be included in the tree 0 or more times. And I was like, that's not right. I'm pretty sure that's not legal in Android land or anywhere else. That seems crazy to me. But I kept reading. And then I got to this one. A widget describes the configuration for an element. And I was like, what the hell? Like, I was just getting used to widgets. What the hell's an element? Nobody said anything about elements in any of the docs I read. What's going on? So I did what anyone would do. I went to talk to Hans. Hans is a senior engineer on the team, also a super nice guy. And I went to Hans and I was like, I'm struggling with this. I'm new on the team and I can't wrap my head around how your whole app is supposed to be represented by this tree of widgets, that could be in there once or multiple times. Like I can't wrap my head around this whole your app is one tree thing. And he said, well, technically your app is actually 3 trees, so maybe that's your problem, which it was. So that led me to these 2 YouTube videos, and I'm going to try and get the slide deck up somewhere where you can get it, so you can find these. What I'm about to show you is a lot of recycled material from these 2 talks. These were internal talks at Google by the original founders of the Flutter team. On the left is Mahogany Staircase, which I think is the only Mahogany Staircase video on YouTube that doesn't have like an old man with like a shop apron on, so you can find it very easily. That's done by Ian Hickson, a man you might know best from his creation of HTML5. He now works on the Flutter team. Very, very nice guy as well. So this is a 2-year-old talk, but he talks about why these things are built the way they are and how they interact. So this is a reformulation of a lot of that. The other one is a talk by a guy named Adam Barth, who is covering Flutter's rendering pipeline, which I touch on briefly. It's still very good if you're at all interested in Flutter. Both these talks are about 45 minutes long. I've watched them both about 6 times. And I'm not lying at all. That's completely true. They're very, very useful. So one of the things I got from these, and it's a good starting place, is Flutter's layered architecture and the notion of aggressive composability, which is a term I've learned since coming on the team. The Flutter has been laid out to be, for each piece to be as loosely coupled to its neighbors as possible and to have as much separation of concern as possible so that you can then compose pieces together to make whatever it is that you want. And so that's reflected in the basic architecture. I don't know if you touched on this before, but I'll go over it again. There are 4 layers here. The very bottom layer is called Dart UI, and this is a wrapper for some native code with some Dart as well, and it's very rudimentary. It's like, I would like to give a texture to the GPU. Please take this texture and give it to the GPU for me. I would like to know how big the screen is. I would like to schedule a function to get a callback at a certain time or something like that. And so that's the bottom layer. Sitting on top of that is the rendering layer, which are objects that know how to call into Dart UI to get things done. So if you imagine a web page, you have a templating layer that reads HTML. It produces a document object model that knows how to render itself on screen. Those are render objects. They can do a lot of other things too. A lot of people sort of take that rendering layer and just put everything in there. And there's nothing wrong with that per se. A lot of great things are built that way. Android views, for example, know how to render themselves in a lot of ways. Also do a whole bunch of other things. But the approach that Flutter has taken, separating concern as much as possible, they said, okay, we'll have rendering objects where you can basically have a tree of boxes that know how to paint themselves and know how to size themselves. And that's what rendering does. And on top of that, to manipulate the rendering objects, we will have widgets. And these widgets will be responsible for constructing and configuring these render objects that actually get drawn on the screen or given to a screen reader or sent out for something like that. And so widgets then sit on top of rendering, and they manipulate rendering the same way rendering kind of sits on top of Dart UI and manipulates Dart UI. And then above that is something like Material or Cupertino, which is an opinionated UI layer that fits some sort of specification. So building on top of widgets by composing other widgets together. So these are the 4 layers. I also learned about the 3 trees of Flutter, and there are 3 of them, the obvious one and the other 2. And I'm going to start just like the architecture. I'm going to start on the bottom and go up. So if you want to render something, you'll have, and it needs to know a particular way to render, there'll be a render object for it. So if I have foo, and I want a widget called foo, and it's going to have a particular way to render itself, I'll have a render foo that matches it. For a rich text widget, there is a render paragraph. For a raw image, there is a render image, and a slew more of them. And they all just know how to render that one little thing by calling it to Dart UI. Oh, that wasn't right. Little cut and paste there for you. So render foo, the objects like this, they know how to size themselves, they know how to paint themselves, they know how to compose themselves out of layers necessarily for something like a stack. Those are the things they know how to do. So then next to the render objects, you have elements. An element is what's actually on screen at any given time. It's what the app considers to be your live UI. So again, if we went back to the web model, you have your document object model. You can have an anchor tag that you make over here that you don't attach to your DOM, and so it doesn't get rendered. It's not really on screen. And so elements are what Flutter considers to be what's on screen at any given time. So the element tree is the trunk. It connects everything else, as you're going to see ad nauseum in the rest of this talk. It is responsible for organizing the tree, kicking off rebuilds of things that are dirty, things like that. It holds references to render objects and widgets, and you'll see later state objects. And it can rebuild things. And then finally, on this end, we get to a widget. And so a widget, as they say in the source code, it's an immutable blueprint for an element. So when you create a widget and you say, hey, Flutter, I want you to put this widget on screen, what it does with that is create an element based on that widget, and I'll show you how. So, and this is basically the same diagram with some children. So if you have a foo widget, you have a foo element with it and a render foo bar underneath it, and maybe bar is a widget that doesn't have any kind of rendering associated with it, like it's a semantic widget, or it's something that's a gesture detector, for example. That's a widget, but there's no drawing for that. And then you can have some children. The children will have an element. And you can also have the same widget in there twice. For example, if bar was an element that could have children, I can give it the same reference for both children, and I'll end up with 2 elements pointing back to the same configuration. So I don't know if anybody's glazing over yet. You look at this is a lot more complicated maybe than what you might have been expecting, right? There's a lot of stuff. There's like 3 trees going here. There's a lot of arrows that I haven't fully explained. There's a lot of objects that have been created. And so you might look at this and think, my God, that's going to be slow. So before everybody freaks out, a couple things. Most of the time, you don't have to think about this whole tree. It's handled for you. You'll be thinking only about the widget layer and not so much about the element or render layer, because you will probably be building things out of widgets that already exist and do the actual rendering for you. If you're using a text widget to render some text, you don't have to really think about how the text is rendering. There's an element and a render object that do that for you. Also, the way Flutter's rendering system and layout system work is different from what most systems use. It's designed on a very, very simple algorithm that's very, very fast. In the worst case, it is linear, and in most cases, it is sublinear to lay out the entire tree and figure out everything's size and get everything right. This is a model of Flutter's box constraints. So if you wrote your own render object, for example, to render something, one of the things it needs to do is determine its own size. And so it gets from its parent something that looks like this. This is your minimum width that you can have and your maximum width. This is your minimum height that you can have and your maximum height. I'll give you that. You tell me what size you are. So, like I said, the parent, you get a minimum width and a minimum height and a maximum width and a maximum height. And the child says, okay, here's my size. That's basically the entire algorithm. And you just go down, it's like a depth first search. You start at the top, you go down the tree once, passing down constraints, and then you pass up a size. So for example, if I had a very basic app here that's a scaffold with an app bar across the top, that might look like this in terms of the widgets and their associated render objects. And so scaffold as the root widget has to be the size of the entire screen. That's one of the rules, because you got to cover the screen. So Flutter would say, okay, you have your max and minimum width are exactly 411, and your minimum and maximum height are exactly 731. You don't get any choice in this. You have to be that size. And so the scaffold would say, okay, let me talk to my children, and it would start passing these constraints down. So it would go to the app bar and say, okay, you can be anything from 0, 0 to my entire size. What would you like to be? And the app bar says, hold on, let me talk to my kids. And it passes all this down until it gets to a leaf. And so the rich text would say, okay, I know what you want me to put on the screen, and so based on the range that I can be, I'm going to be 120 by 80 to just display this little title screen. And so it passes its size back up to text. Text says, that's awesome. I don't do anything, so I'll just pass that back. Then it goes to padding, and padding's like, okay, I'll take your size, I'll add my padding to it. Now I'm a little bit bigger. Passes that up. App bar's like, cool, I'll take your height, but I'm the entire width of the screen, so I'll add that on. And then it passes it up to scaffold. And scaffold goes, okay, so you're 411 by 100, so the body can be the same width, but now it's got a little less height to work with. So I'll start passing that down that leg. And so that goes down the tree the other way. Eventually it comes back up, and scaffold can report its size. So, taking that all together, you have a system that can handle these very, very deep trees of widgets and elements and render objects because it's using algorithms that are linear instead of like n squared or n log n or what have you. And you also have a system that allows you to separate out things, bits of logic, as much as possible. And so that leads to things, it leads to very, very stupidly simple widgets, which is one of my favorite things about Flutter. And if you haven't seen padding before, I think this is just great. Every UI system I've ever used, everything had a padding attribute on it, just about, right? There was always dot padding that you could do. In Flutter, that's not the case. In Flutter, almost nothing has a padding attribute. If you want padding, you wrap it in a padding widget, and you give it your widget as a child. And so you're using composition there instead of having some ancestor where everything has a common padding property. And so the padding widget just needs to remember how much padding there's supposed to be. So on this side, if you had a widget, that's all it has to do, other than exist, is remember how much padding there is. And the render object just needs to be able to do a simple calculation. Set my size to whatever my child was, plus the padding that I can get from the widget, and then offset my child a little bit within my bounds, and I'm done. That's like all the functionality you need. And so you get this widget and this render object that just do that. Decorated box is another widget that I think is just hilarious that it exists. It decorates a box. That's its only purpose in life. You give it a decoration and a box, it will decorate the hell out of that box, right? And it's, again, very simple. All the widget is a configuration, so it holds on to what box do you want to decorate and the decoration that you want for it. The render object just sets its size to whatever the child is and then applies the decoration. That's its only job. So you don't have to have a border property on everything, for example, or a background color on a whole bunch of stuff. If you want to decorate if you want a background color on a text widget, for example, you just wrap it in a decorated box. And that's how you get that functionality through composition. And like it leads to just these very small, very specific widgets, like sized box, which is just a box with a size. Fractionally sized box is like a grid view if you ever use like bootstrap grids where you're like, I want n equals 3 all the way across, those sorts of things. That's how you can do this. Okay, and so getting on to some actual coding here in a second. So the question is now, if this is what the tree looks like, how does this come into being? How do you make this, right? How does it all get constructed and maintained? And let me pop out and grab some code. So let's run some stuff. So here we go. So show of hands, how many of you have actually played with Flutter a little bit in the past? That is rad. Okay, thank you. So it looks like half to 2/3, I think. And I'm just going to demonstrate hot restart here. Much better. I'll make this cleaner in a second. I'm trying to keep the widgets to an absolute minimum. So the main is the entry point for a Flutter app. And it's making a call to hide the battery display. And then it's doing the thing that I want to talk about, which is calling run app. Run app is the thing that kicks off the construction of that whole tree that you just saw. And in this case, I'm giving it a widget, and I'm saying, this widget is my entire application. Please run my app. This widget is my app. And Flutter says, OK, I'll get to work on that. So this is the actual code for run app. It's 3 lines. And the one I'm most interested in is attach root widget. So you get a widget, and it attaches it to the screen. That's its entire job. And so here we have a rich text widget, which is the one that you just saw me creating in the source code. And rich text is a very simple widget. It takes the text and some configuration data, and it just renders text. That's all it does. It just draws text on the screen. So you give Flutter a widget, you say, this is my app, please take care of it. And Flutter says, OK, my tree is made of elements, so I need an element. And so it goes to the widget, which is all it has, and it says, hey, can you create an element for me? And the widget says, yes, I just happen to have this create element method that can create the right kind of element to represent me in the tree, a live version of me in the tree. And so render text has no children, and it renders itself. So it gets this very short name, leaf render object element. And that gets popped on the tree. And it gets a little reference back to the blueprint that it was created with. And so now I've got an element representing what my app is at that given moment. I've got a configuration for it, but I still need to draw it. So leaf render object goes back to the widget when it gets mounted. This is the function that's called when this particular element is mounted on the tree. And it asks the widget for render objects. Like, OK, you're the configuration. You know basically what should be drawing you. So I'll ask you for a render object. And the widget has this create render object method that pops out a render object properly configured with all of the attributes from the widget. And run app says thank you. I'll pop that onto my render object tree right here. I'll give the element a reference to it in case it needs it later. And now I'm good. I have my tree of boxes over here that I can draw on the screen. And so it lays them out and paints them. And so that is a very, very simple example of how a widget, an element, and a render object get created when you call run app. So what happens if we run it again? I can go in here, grab my code. What happens if I call run app twice? Which you wouldn't normally do, but you totally can. And so before, when I called run app, I got something, and now when I run it again, I see or other has popped up. So something has happened to replace whatever happened with the first one with this new configuration. So how the heck did that work? So this is what I had at the end of that first call. And then when I call run app again, I got another widget that shows up. I got this new guy, this interloper. It's like, hey, I'm a different rich text widget, and I'm now supposed to be the config for the root widget. And so Flutter has this very nice thing called canUpdate, which is a static method in the widget class. And it says, if you give an element a widget that's the same runtime type, and they don't have mismatched keys, the element can just stay there. It's already basically set up to represent that kind of configuration anyway. So it could just hang out and update itself to point to the new widget. So you get rid of the old widget, you put the new one in its place, and the render object over here still says something. That's still the same object, so we need to update that. Fortunately, the widget has an update render object method, where you can give it your existing one, and it'll call all these setters and update it for you. And so at the end of this, I now have my new widget, my same element, and a new render object that's got the right attribute to go render the text correctly for me. And so now I'm done, and I can take this tree of render boxes with its one element, and I can go paint that to the screen. Yeah?
When you change the widget, but it hasn't changed the element yet, is that what it means when you say the market is dirty?
Yes. So An element, yeah, an element is dirty has a whole bunch of meanings in Flutter because there's a whole bunch of trees. So elements can be marked dirty, which means they need to be rebuilt or updated with a new widget. A render object can be dirty for painting, layout, or I believe semantics or compositing. There's a whole bunch of dirtiness in Flutter if you go into it. So yeah, actually hot reload. If you mess with Flutter, you've seen hot reload. What it does is it ships new code over and then marks everything as dirty as it can be. It flips every dirty bit on everything. So there you go. All right, so what happens if I do something like this? Say, I'm not going to show the code for this, but say I ran run app again, I gave it a completely different kind of widget. So instead of text, I would like an image now. I still get that can update call. It would look at the runtime types and be like, this element used to be for this kind of widget, now it's for a completely different one, so I can't reuse this. And so everything goes away. And then, just as it happened the first time, Flutter asks this for an element. It gets an element. And the element asks the widget for a render object. It gets a render object. And I'm finished now. And I now have this new render object that I can go draw and paint on the screen. So that's one row in the tree. What if I had a couple rows? What if I was using a center widget, for example? So say I had something like this, where I took my rich text widget that I've been using for a while, I just wrapped it in center. Center is a very simple widget, just takes one child and centers it in whatever its parent is. So I could run this. And so now it does the same basic thing, and I get that up. Let's take a look at how that worked. So I call run app. I've got a center widget with a child that's a rich text. Flutter asks the center widget, hey, can you create an element for me? It gets a single child render object element, which I'm surprised I could fit in that box. That asks center for a render object. That gets popped out. And then it goes to the child, and it says, okay. And I added an attribute to the rich text. And then it goes, okay. I am a single child render object element, which means I should have a child. So let me go look at the widget that I've been given. Does it have a child that I can use? And then that same process, that same little thing that run app has been doing, it does that same thing one level down. And it goes, okay, I have a widget. I'll ask it for an element. And then this is a render object element, so it'll ask it for a render object. And then I'm done. Now I can go paint this tree of boxes. And I get my centered text. So that's how that pops up. And if you wanted to update widgets with children, so you have a new set of widgets come in. It works just like before. I have a new center with a new rich text. The old one goes away. So the new center is mounted first. And it calls can update widget. It's the same type, so the element can stay. The render object would just get updated. And then it goes down one level. It's like, all right, I have this kind of widget. I have this kind of widget. I have this kind of element. They still match because it's still a rich text. It goes, okay. The rich text has new text here, so I'll call the update for my render object, and that's how that new text value gets over there. And I'm done again. I can go draw these. Does anybody have any questions on this, by the way? Anything? Yeah, go for it.
So if you have the padding and the center and all those things you apply to the widgets, those things are also widget themselves.
Exactly. Your entire app is a widget. Yeah. Oh, like I said, normally not giving talks. So he asked about padding and these other things. Are they also widgets? That was basically her question, right? And yes, the tagline for Flutter when it first started was everything's a widget, which is really basically true. Everything, the gesture detector is a widget. Accessibility things are a widget. Just about everything you have will be a widget or something that a widget is holding on to. Like if you have a stream of data coming from a network, there'll be a widget hanging onto that so other widgets further down can get data from it. So yeah, that is how that works. And it's the same if there are multiple children too. So if you had a widget, like a column could have multiple rich texts in it. And the same basic process is going to happen for that. Each of those child widgets will get compared to the element that it corresponds to, and the render objects will be updated. Okay, getting on to something that's more exciting based on what you guys have been talking about before. Stateless widgets. So a widget is a configuration for an element. A render object widget, which we were just looking at with rich text, is a widget that knows how to create a render object to paint it. A stateless widget is a widget that knows how to build its own children. And that's really about it. And I will show you an example right here. So you could, if you really wanted to, build your entire app in Run App. You could just have 1,000 different constructor calls and build all the widgets there and give it to Run App, and Run App would do all this stuff. But that strikes me as a wee bit unmaintainable. So imagine this Run App call, and it's creating a center widget that has a column in it, and then it has 3 padding widgets that, a little further down, have a text widget in them. And this is not dry. I'm repeating all kinds of code here. So I would love to take this out and encapsulate it somewhere so I don't have to look at it 3 times. And I can do that with a stateless widget. Yep. So here's a stateless widget, and that can do that for me. So stateless widget, you could give it some data that would be its configuration. And its purpose in living, really, is just to have that build method. So this widget, rather than having a child that's given to it when you make it, you just give it some parameters. And then anytime you want to, you can say, hey, build yourself some children, please. Using this is where you want, like if I wanted to move the stateless widget somewhere else in the tree, maybe the default font is different there. And so when that widget goes up there, I want to rebuild its children. And so I can call this method whenever I want, and just say, whatever you think your children should be, build them and give them to me. Right? And so then I could go up here, and I could replace these with text. I could do 1. I give it, this is just taking a padding and a text, and get rid of all this other crap. If you've ever seen my videos, this is why I always speed up my own typing. So I could do something like that, and then I could hit hot restart here. Of course it did. Well, forgot text direction. This is actually kind of handy. One of the nice things about this is that you can rescue yourself without restarting your app. When you get a red screen of death like that, it's only the red screen of sleeping. There we go. Again, if you haven't seen Flutter before, that has saved my ass so many times. I just completely broke rendering and didn't even have to stop the app. I just fixed the code and shipped it over. And so now I have the same thing, but with much less code. I can go use this widget wherever I want, just like you would if you were a decent programmer programming in anything. So how does this work? Basically the same. Because it's just a widget with a twist, as almost all of these are. So my padded text widget, say I just gave Flutter that, my stateless widget, and I was like, here's my app, my entire app is this padded text. Flutter would go, okay, padded text, can you make an element for me? And so it pops out a stateless element. Stateless element is basically just an element, except it knows how to ask something for children. So stateless element would be great. I'm a stateless element, I've just come into being, hey padded text, do you have any children for me? And it calls the build method. And so padded text goes, this is where it calls the build method when it gets mounted. Just like the other one, when it got mounted, created a render object. This one, when it gets mounted, goes, do you have any kids? And padded text says, yes, I have this padding. It has this text as a child. Here are my children. And so stateless element says, sure. I'll ask for an element from padding, which I didn't put the full name on there because gross. And that one gets a render padding that it gets from the padding element. And then it goes, hey padding, do you have any kids? And it says, yes, I have this text. And so text itself is also a stateless element. I kind of hid that earlier. Text actually makes a rich text underneath it. And so we continue on down the tree from there using the same process that run app has been using the entire time. And so there's really only one more element under there, which would be a rich text, but I don't have much room. So that's how you would take one stateless element and build it. What happens if you rebuild if you come in with a new widget? Just like before, we had a rich text that said something, and I was like, okay, I would like another rich text with something different. What happens if you do that with a stateless widget? Well, if you bring in a new padded text, it's the same basic process. It says, okay, I'll call can update widget. You guys are the same type, so my element can hang out. I'll just replace you. And now I don't trust my kids anymore. I don't trust my own children because you're a widget with a different configuration. So you might have different children than my previous widget would have. So it calls that rebuild. It calls the build method on the new one. And this is where it's doing it. So it's stateless element. It has a method called perform rebuild, where it calls build. And I don't have the code in here, but it actually delegates that build method straight to the widget, which is how it gets called. And so padded text produces a new set of children. And Flutter goes, that's awesome. I'll get rid of these old kids. I'll reuse this element because the padding is the same. I'll update my render object, and I'll reuse the text as well, and then on down. It has text for its children. So that's cool. Yeah, go ahead.
I'm sorry, you said it doesn't rebuild the other elements?
It does not. Let me go back. So let's start here. Is that about where your question popped up?
Just at the last second.
Oh, sure. Oh, so I was hand waving some stuff. So basically, the same process that it used in the first that you've seen to update an element based on a widget, you see that again. So here, padding is a single child render object element, which I have not put on the screen, but that's its element. So its element can reuse padding because it was using that before. So that gets linked up. Element goes, okay, I'm a render object element, so I know there's a render object. I need to update it. So it goes, okay, hey, new padding, can you update this render object for me, just in case you have more padding than the last one? And so it would update that. So if you had padding of 24 before, now you have 36, that's how your render object now knows that it needs to pad more. The stateless element, which lines up with text, goes, okay, I had a text before, now I have a new text, and so I can update myself to point to this new widget, but since I'm a stateless element, it's going to rebuild its children as well. And that's the part I'm sort of hand-waving. Underneath this text, there would be a number of semantics-based widgets for screen readers and things like that, and then eventually you get down to rich text, which actually does the work of drawing the text. All right, any questions based on anything you've already seen?
How is this similar or different than Shadow DOM?
Shadow DOM for like Polymer is using and things like that?
Polymer or
okay. Let me remember my Polymer stuff from like 4 years ago. So Shadow DOM is creating separate subtrees of DOM within an overall overall tree that are scoped they're like scoping boundaries basically. I got that right? Sure. That's not really something you see here. You don't quite need it in the same way. So for Shadow DOM, you can do things like have your own CSS properties and things like that, and it's very handy for that. With Flutter, the parents don't even really know their children, and they don't even really know their own parents. They're so loosely coupled. For example, when Flutter calls into an element to say, you might have some children that you need to update, I want you to go update them. It tries to call this function called, screw it, let's go find it. Open source. Let's go see if I can find actual element. Yeah. So in here, there's a method. Visit children, where are you? Here it is. If everybody can see this, there's a method called visit children. And so in Flutter, when we had set up that stateless element before, and it built its children, and Flutter was like, okay, element, here are the new widgets. There's a point at which it needs to go into the element beneath it and say, I have new widgets for you. You need to do stuff based on this. And the way it does that is by calling visit children on its child, and it gives it a function and says, just visit your children, call this function on each one. It doesn't know how those children are organized. They could be in a map, they could be in a list, there could be none of them, there could be one of them. It doesn't know any of that. All of that is up to the child. And so that's the level at which the ignorance boundaries are just normally in Flutter. Almost everything that can be encapsulated or separated out has been done that way. And it's been done that way from the start. So I don't think they ever needed to introduce something like Shadow DOM to have that function, to have that simplicity that it provides. When you do, I've been showing running app from the root. Later when we get into stateful, actually right now when we get into stateful widget, there are ways to kick off rebuilds of the trees at a subtree position. So like if you have, again, hundreds of widgets potentially, and you have one like way down here that like, if the user looks at it funny, it needs to change color, right? It's the mood ring widget or something, I don't know. But that can trigger rebuilds of just itself. And none of the rest of the tree necessarily needs to know. And especially like if it's in a fixed box where none of the constraints even are going to change or anything like that. None of the tree needs to be laid out any different or painted any different necessarily. And so those sorts of things have been considered as first principles of the design, I guess I would say, if that makes sense. Any other questions, by the way? I don't know if this is, like I said, I don't normally give talks like this. I figured it was a friendly audience, so, and you would just stop me if I was going too fast or wasn't explaining anything clearly enough. And also I have the entire source to go look at, which is just a wonderful cliff note. Okay, let me remember what the hell I was doing. So stateful widgets. So a stateless widget is a widget that knows how to build its own children. A stateful widget is a widget that knows how to create a state object. And so let me go in here and do some coding. Here we go. So let's say, let me restart. Let's say I had a stateless widget, and its entire job in life was to take two properties, a label and a count, and then build widgets to render those on the screen. It's very simple. That's its entire job in life is to do that. And I'm like, that's awesome. But I'd really like to have an app that people can interact with and do stuff. And I wouldn't have to run rebuild, I wouldn't have to run app anytime anything was going to change. And so the way I can do that is by going in here, and I'll hit Alt-Enter, and I'll do convert to stateful widget, because I'm lazy. And it's going to make some new code for me. And so I now have two classes. I have my widget, which is now a stateful widget, and then I have this state object, which is typed to match my widget. And that build method that I had before is now moved down to my state object, and it's referencing some of the properties of my widget. So the state object is now in charge of building the children, and the widget still holds on to some things for me, but it creates the state object. That's now its main job. And so with a stateless widget, I'm not allowed to, it's stateless. The state has to stay the same. So I'm not allowed to change properties on the fly. But with a state object, I could take this count, for example. What the heck did I just do? I could pull that out. There we go. And I can move it down here. And I don't want that to be final anymore. I'll give it an initializer for 0. And then in my text, and this is, I haven't really touched on it, this is just string interpolation that a number of languages have. People are nodding, so I'm going to assume everybody's familiar with this. So I'll get the count right out of my state object, and the label that's not going to change, I'll keep getting that from the widget. That's never going to change. I'll get it from my widget. The count, though, I want to update. So let me update this constructor. And I'll take that up there. I think that's good. Go ahead and run this, make sure it doesn't crash. So okay, now I've got the state object that has a build method, so somebody could call that to build some children. And it's also got a mutable property, whereas I used to have one that was immutable. So that's pretty handy. What happens if I go and try run app with that. Start with my widget, just like always. It has a label of taps, that's its configuration. And Flutter goes, okay, make me an element, I'll put you on screen. So it gets a stateful element. Stateful element is an element that knows how to ask for and then hold on to a state object. So instead of creating a render object or asking for children run away, it says, hey, can you create a state object for me? And the widget says, sure, here is the state object that matches me. It calls that create state method, and the count starts off at 0. And then the element says, great, I got a state object. I'll ask the state object for some children. It calls that build method. And the state object kicks out a text with that label from the widget, count from the state object. That gets mounted in the tree. Text is a stateless element. That makes a rich text with the appropriate text. That gets its own element. That gets a render object that can actually build it. And now I can go and give my tree starts way down here now, but I can give this tree of boxes. It's only one box, but I can give that to Flutter and run it and render it on the screen. But I said make it rebuild, which is the fun part. So let's do a little bit more coding. This will be fun. I forgot to paste the code in here. All right. So the way that you trigger a rebuild with a stateful widget is inside the state object using a function called setState. And when you call setState, you give it a function that's going to make the change that you want made, and it will, and in response, it will execute that function, and then, and this is the important part, it'll mark the element as dirty. So it'll trigger a rebuild. So I can come in here and say, let's wrap this with a new widget. I'll use a gesture detector. I'll come in here and I'll say on tap, I want you to set state. Then I'll give it a little function to run. So I'll say, okay, you don't get any parameters, and I want you to increase the count. And so when I tap on this text widget now, there's a gesture detector widget around it. It's going to detect my tap, and it's going to call this little function that then calls set state, and it mutates one of the properties and triggers a rebuild.
If
Yes?
you go back to that for one quick second, one of the things that we found in Home Day Q&A that really helps people out is when they're trying to learn about set state, we tell them to read the word that's not there, which is set state with.
Oh.
And then the camera. And it's suddenly the light goes on over there.
Interesting.
Set state with whatever is in there.
That is exactly what you're doing. And so I'm going to show you what set state actually does under the hood in a second. That's a good point. So let me get back to this real quick. So I'd like to increase this count in my state object to 1. And so I'm calling set state, and there's a bunch of mostly asserts in set state to make sure that you're doing it all right, which is one of the nice things about Flutter. Most of the common things that you could screw up, they generally have a nice error message for. I think I've seen all of them at this point. But set state basically just does two things. It takes your function and it runs it. If it gets a future as the result, it says, hey, you screwed up. You're not supposed to give me a future. You're supposed to be read synchronously. That's one of the things state is supposed to be able to do. And then it marks its element as being in need of rebuilding. So if we do that, we have my count state here still at 0, but if I were to tap on it, that would go to 1, and then Flutter would say, you know what? My state object has been updated. I am now marked dirty. I don't trust my children anymore. So I got to ask somebody to rebuild children for me. And so it turns the stateful element knows to ask the state object. So the state object kicks out a new text. And because it still has that same label from before, the widget, that one doesn't change. So it still taps. It combines that with the new count from the state object to make a new text widget. And the same process that you saw before, the stateless element goes, ooh, I got a new configuration. I got to ask it for new kids. So it gets a new rich text. Rich text comes in. The render object is updated. And now we can go render this and paint it to the screen. And so this is, and maybe this is a good thing. This is about the last thing I have to tell you. What happens if you replace the stateful widget? And this is the really cool part. There are, has anybody seen animated container in Flutter before? We have a few nods. Animated container. We made a video for it a couple weeks ago because it's magical when you see it the first time. You don't really know how it works. At least it was to me. The way it works is you have an animated container that you make. It's a widget, and you say, okay, your color is this, and here is a duration in case you need to animate anything later. I'll give you that. Your width and height are this, and here's a border for you. And you make that widget. And then if you rebuild that widget in the same place later with a different color, say, or a different height and width, it will automatically animate the difference between whatever you gave it the first time and what you're giving it the second time, using the duration you gave it. And the first time I saw that, I didn't know what I'm about to show you now, and so it just looked like magic. It was really cool. I just made a widget, and then I made another widget. It was smart enough to know the difference between the two widgets, and I learned the word lerp. Does anybody know the word lerp? Probably should have known that beforehand. But it lerped things for me, and I was like, that is amazing. And it did it through this process. So what happens if, say there's a change above, or call run app again, and I have a new widget of the same stateful widget class. So before I had a my count, and it was taps. So say I want a new my count, and I'm changing the configuration. I'll say pokes, because hopefully Facebook isn't here to sue me. So I'll change that. What happens then? Well, just like before, it calls can update, right? So stateful element goes, can I update with this widget? And Flutter looks at it and is like, okay, same runtime type. I don't have any keys because they're completely out of scope for this discussion. And it goes, okay, you can all stay and you can be my new widget. So the old widget goes away. The new widget comes in. The stateful element now points to that widget. The state object now gets a reference to that widget because the state object points to the widget it associates with. But the element and the state object hang out. They don't go anywhere. So that mutable state that we had here is still there. So the count is still 1. It doesn't get remade and set to 0. And that's how animated container does its magic. It has a state object here that can hang out in between the two. And there's a method called didUpdateWidget called on the state object to say, oh, by the way, I changed your widget. So you've got a new configuration. You can stay, but you have a new configuration. And this is where animated container starts setting up animations. And so in this case, if we just keep going down the tree, my count state gets to hang out, but it doesn't trust its children, just like before. So it kicks out a new text using the same count from the state object, but the new config from the widget. So you get a different text string, and then that gets propagated down the tree to a new render paragraph with that text. So, knowing all this, as I did after many weeks of study, I went back to talk to Hans. And I said, it's been like a month now that I've been on the team. I'm really thank you for your help. I'm really getting my head wrapped around how the app is represented by these 3 trees. It's amazing the way they all 3 of them work together. I just wondered about these 3 trees. And Hans was like, well, when you think about it with focus and state and layers and semantics, it's really like 20 trees. And so I went back to reading after that. I'll let you know when I finish that, when I've got them all down. And that's my talk. Hopefully you guys enjoyed it and got something out of it. So. I don't know what you guys normally do. I'm happy to take any questions anyone has or whatever. Sure. Oh.
Please, go ahead. I see you're using IntelliJ up there. Does it give you different functionality than using Android Studio?
Sure. So does IntelliJ provide different functionality than Android Studio? I don't think so. There are 3 IDEs for Flutter that get basically first-class support from the team. from Google. IntelliJ is certainly one of them. That's my IDE of choice. Android Studio, I believe, basically just uses the same plugin because it's also based on IntelliJ, as I'm sure you know. And then Visual Studio Code is the other one. And there's also someone at Google who is working on that plugin and tries to keep feature parity with what IntelliJ has. I think IntelliJ is a little bit ahead, but don't quote me on that. But yeah, the idea is that you should be able to use whatever you want. Like that's sort of the ethos. You can also use VI and the command line if you want to. A lot of people on the engineering team do. I'm not that cool. So, well, you had a question. Right?
Yeah. How do you? I mean, what's the support level for accessibility?
Oh, sure. So what's the support level for accessibility? That's something that was I think a sprint goal a little while back, and they did a whole bunch of accessibility stuff. We've had there's a team for accessibility at Google. They have come in to consult on how to implement all these features. I don't actually know the nitty-gritty of it, but I can say this. It is certainly a goal for the team for these apps to be accessible, because not only is that the right thing to do, but it matters to anybody who's building apps at any kind of scale, right? We all want to be available to as many users as possible. There are certainly, if you turn on a screen reader and stuff like that, there are widgets to do that and those sorts of things. I don't know the details of it though.
There is one more.
Sure.
I don't know what because I listened to some talks by Jeff last time. Then someone asked the question that what are your plans on that? The usual answer is no comments. Anyway, I would ask your suggestion on this. So when I am writing apps for Android specifically, I can just use it back and forth between the layout types on the XML side. I know there are some pain points, but still I can just get a quick glimpse of what it might look like, not exactly what it might look like. I can do this in parallel with multiple screens on, multiple XMLs on, and this kind of works a bit. Flutter, I know the hot reload is super awesome, but how can I then view two different views on the emulator? Or is there any kind of support that?
Oh, that's an interesting. So let me make sure I got this right. So you're talking about when you're developing for Android, it's easy to pull up two different views in the layout editor, and you can do this in iOS too. The interface builder, you could pull up two different views and see them simultaneously, and work on them simultaneously.
Yeah, right. So maybe just to compare, or just for whatever reason you want them side by side.
I really want to do an experiment now.
Unless you have an emulator.
Sure. So I was expecting a different question, which we get a lot, which is, are you going to build something equivalent to Interface Builder for Flutter?
No.
And I'm sure you've heard the answer to that, which is that we just want to make hot reload work so well, you don't really find yourself needing it. I believe you could get what you're describing. I haven't tried this, so again, I know there's a camera, nobody quote me on this. I have certainly gone in here in IntelliJ. I've got this open. I can go in here and launch an Android emulator, which is running our...
Is the question whether or not you can have both running and hot reload at the same time?
That's what I was going to suggest, which you certainly can do. And so you could, in theory, have different states of the app. One is in one state and one is in another state. And I believe you would have to hit the hot reload button manually, but I think you can ship code to both and maintain two separate states, one in the first emulator and one in another. And I'm probably going to try that in my hotel room tonight, just to see what that's like. But that's the best answer I have right now. Yeah, sure. Who else?
Two real quick. One after the first one. Could you show the difference between hot reload and hot restart, and explain when you would use each? And the first one, a lot of new people always say, "Where can I go to learn?" So other than talking to Hans and begging Hixie, what helped you to get started back in April, May?
Sure. Let me try and do those in order.
They can do.
Sure. Let me try those in order. So the first one you were asking about, what's the difference between hot reload and hot restart?
Right.
Let's start with that.
And when you would use it.
Sure. And I'm just going to kill this emulator. I do not want to save that state. It's gross. So these are very small because they don't get bigger. But if you look up here, you have the little the bug to launch in debug mode, and then you have the lightning bolt next to it, which any Android developer is familiar with both of those symbols, certainly. They do two different things in Flutter. One is a start or hot restart, and the lightning bolt is a hot reload, which is normally also kicked off if you save a copy of your file to the file system. There's a file watcher that'll kick off a hot reload. So the way hot reload works, and I sort of mentioned this before, if I pull up, let's pull up the tree real quick. The way hot reload works is when you're running in debug mode, you're running it with a VM. It is not compiled to pure native code. You're running in a just-in-time debugging VM. And so when you trigger a hot reload, it ships over new code to the device, to the VM that's running in this shell of an app on your emulator or your device. It ships over new code, and it goes, okay, I'm going to mark all of these elements for rebuilding, and I'm going to mark all of these render objects as dirty for everything they can possibly be dirty for. And what that means is basically all the widgets sort of go away, because all these elements are getting rebuilt. Your root widget stays, because there's nobody to rebuild it necessarily. But everything else basically gets rebuilt with the new code that you added and new configurations that you added. And that is very, very good. If you've messed with Flutter, you've already seen it, for tweaking UI and doing things that used to be fairly annoying, where you tweak a property and then 30 seconds later your app would load and then you have to navigate back to where it was. With this, you don't have to do that. You can ship new code over. All of those state objects that you saw before, those would stay. So if you've navigated to something and you've hit a button 4 times and now you're looking at a widget, that state is still there. So when the widget gets recreated, it gets recreated using the new code, but just the way it had before. And so that is a hot reload. Hot restart is much simpler. If hot restart, it moves new code over, then it throws away everything. Literally, like the heap and the stack go out from the Dart, and it just calls main again and re-enters your app from the beginning. And that's why, if you were paying attention, when I kept calling run app over and over again, I was hitting for a hot restart instead of a hot reload, because that's how I get back into main to call all that. So that was part one, I think. And the other question you had was, what are some good resources that helped me learn that people can also look at? There's certainly more now. We have like 7 people on the DevRel team, I think. All of us are cranking out resources as fast as we can. If you don't already know about it, we maintain a samples repo, which has the samples that I've had time to write while working on other things. I can't wait to get more in here. But it also has a curated list of samples, and that's one thing. This is not the only curated list, by the way. There's some GDEs that maintain a couple. I actually linked to one here that someone has made on Google that has a lot more stuff, or made on GitHub that has a ton more stuff. There's a very vibrant community for Flutter. They make a lot of stuff. This is completely new to me, coming from mobile ads, where people were glad we existed, but they didn't really get jazzed about what we were doing and make a bunch of samples about it. And so one of the challenges for me is keeping up with all this. And so this is a list of good samples, and we have ones that are made by GDEs and just that we think are really good. I can call out a couple. The Flutter architectural samples, I've sent everyone I've ever talked to these samples. They're made by a guy named Brian Egan, who is basically implementing to-do MVC over and over again using a variety of architectural patterns for Flutter. And it's a great resource. I definitely used that when I was starting to just see, like, what does Redux look like if you're using it with Flutter? What is the block pattern? How do you take streams and make an app based on streams? And so you can look at his stuff there. There's some stuff in the Flutter team which is marked, and things from the community have their various GitHub braggables next to them. So that's one. There's also a page that will be up on our website soon that has video resources that we've made and that people in the community have made. We have our first Google developer expert in India for Flutter. He is on YouTube as MTech Viral. And he has made dozens and dozens of videos of him just sitting down and doing really good Flutter code for various things. And so I like to learn from videos. That's why I make a lot of videos. And so I've definitely benefited from his stuff too. So those are just a couple. If you catch me in a minute, I'll probably have thought of 3 more. Anybody else have I don't know where we are on time, by the way. Okay. Yeah. Any?
Did you get tired?
Okay.
Does the Flutter team plan on supporting any of the platforms like Desktop?
Sure. So, and again, take this with a grain of salt. I don't know of an official effort that's on our road, like officially on our roadmap for desktop. That may be because I've missed something. Let me say also, by the way, if you want to know what's going on with Flutter, you can just go to the repo and look at what the tickets are in there. It's all developed in the open. And so if you ever are curious what's going on with anything, you can go in here and start looking into projects and things like that. And just see what people are working on. Like when they had a sprint recently for better Cupertino widgets to produce a more iOS-y feel for people that were doing apps like that. And all the work was planned out there on GitHub. So if you were curious what was going on, you could go and see it and contribute and or file bugs and feature requests. But to get back to your actual question, people have done it. There is a dude in London who made a desktop like runner for Flutter apps. I've seen it. I thought it was hilarious because I wrote like a little reversey game. It was like an app that I wrote to just teach myself some stuff, and he used that as one of his samples. And I was just surprised it didn't break when it was run on something other than like the one emulator I'd ever tested it on, you know. Yeah. So I don't know of anything beyond iOS and Android that's really getting any focus from the team right now for 1.0 anyway. Anyone else? Yeah. Shoot.
So I haven't found a definitive answer yet. Do you know how to handle the best practice to handle like the equivalent of Angular services? So like application-wide data storage?
Sure. So you have some data that's sort of like conceptually is at a global level basically.
Yeah.
How do you get to it? One of the things I didn't have time, I'm glad I didn't put it into this deck because that talk went for like an hour. But there's a widget called Inherited Widget, and you may be familiar with it. Okay. Let me do something real quick. Let me pull up an app that I am working on. I don't know if any of you guys are actually Europeans, but there's a conference series in Europe called Devox, and they run smaller conferences called Vox Days, which are small conferences that they do. And we were looking around for a good big app to do as a sample, and so we're making a conference schedule app for them. And let me just show you this main here. So here's the main for this one. And you can see main is making a widget and giving it to run app. It's the Vox Day app widget. And that's making a store. This is using a library called Reblock, which is a variant on Redux. So are you familiar with Redux by any chance? Okay, anybody else not familiar with Redux? Don't be shy. I wasn't familiar with it until like 4 months ago. Okay, sure. Redux is an implementation of the Flux pattern from Facebook. The main thing that you would want to know here is that it has a single store that holds all of the sort of app state for your app. And so you have this one object that holds the state for your entire app, all the records and everything else. And so what this does is it makes a similar type of store. And let me go find, here it is. It uses an inherited widget to provide access to that store all the way down the tree. So the way inherited widget works, and again, I'm sorry I didn't have time to show you guys this. If we had a whiteboard, I could diagram it out in like 30 seconds. But imagine you have a widget that's, so imagine you have this widget way up at the top, and it can hold a reference to this store, for example, or a service that's going to have some data for you. Way down here, you have a widget that's going to display some data from that store. And you know, when you put this up here, you have no idea what's going to end up down here. You can move this widget can move in the tree. Some intern comes in and like changes the way all these widgets work, something like that. You have no idea. So the way that you can access that data from way down here is by using an inherited widget. You put an inherited widget up here, and you say you extend it just like you would stateless or stateful widget. And in your class, it's an inherited widget. You have a property for this thing, store. Let me go back to IntelliJ real quick. So I have this inherited widget that's going to hold on to my store. And then there is a call that a descendant can make, and please don't try to understand, I'm just looking for one call. Here we go. The widget can make a call called inherit from widget of exact type. And it can say, here's a type of widget. I would like Flutter to go up, I would like to go up the tree and look for a widget of that type. And when I find it, I'll get a reference to it so that I can pull the data I need, and I can use that in my build method. And this is the cool part about it, that widget will remember that I asked. It will remember where I am in the tree, it remembers my element that corresponds to me. And if that widget ever changes, if another widget comes in and replaces that one, the widget down here that descends from it will automatically get marked dirty. So if you have, for example, an Angular service, and you can have an inherited widget that holds a reference to it, way down here you can have a something something descendant or something. In its build method, it calls that inherit from widget of exact type. When it's building, it'll get a reference to pull out the data that it needs and use it. And then if the widget with the service ever gets busted or whatever, gets replaced by another one because you switch servers or something like that, this one will automatically get rebuilt using that new widget. Hopefully that pantomime did a little bit to explain it for you all. Yes?
Question about widget. Let's say I have 2 pages and I want to go from one to another.
Mm-hmm.
Do I get a separate widget tree, or is it the same widget tree and something else happens?
You get different parts of the same widget tree. So repeating the question, what happens when you want to navigate from one section of an app to another? And how does that work? So there is a widget called Navigator. If I can find it. Yes. And Navigator actually makes a child that's an inherited widget, so you can find the Navigator from up above you. But a Navigator widget handles that navigation. So it's Flutter. Everything's a widget. Even that is a widget. So a Navigator can use routes to go load other widgets for you. If I was in here in main, for example, way up here, I have this generate route, where I'm generating a, based on some settings for a route, I'm going to return a route, and a route is just a thing that can build widgets. So the Navigator will say, okay, I'm trying to navigate to this particular, here's a string that represents a route, and I would like to navigate to it. And it calls this method, and it's like, oh, you're trying to navigate there? Okay, here's a function to go build the widgets that represent whatever the hell that is. Go call that, and then do whatever animation you want to do to, like, so if it's like on iOS, and it's supposed to like swipe in from the right, the Navigator can do that animation. On Android, it might, by default, have a different animation where it's coming up from underneath. You can give it your own transition animation if you want to. But that, too, is a widget. And so you would end up, if you navigate from, you can do things like push replacement or push named, things like that. So if you push your replacement, whatever you had before, off it goes. It's not in the stack anymore. If you push a named route, whatever you had that you were looking at, it keeps a copy of. That widget gets moved off stage, they call it. So it's not getting rendered anymore, but it's still hanging out. And then the new one gets built, and that is displayed at that point.
So how do you know which widgets are designated for what stage?
You would have, so in this one, for example, I have my routes here that I'm making, and I have a conference detail screen that's the widgets for a conference detail list. And then I have a speaker detail screen that represents the details for a speaker. So if I were navigating between these, if I was looking at speaker details, I have this little subtree that represents, here's a scaffold, here's the lists and things like that. And if I navigate to a new route, that one gets moved off stage. There's an off stage widget. The new one gets, this method gets called, a new route is generated, widgets are built for it using this constructor. That gets mounted in the tree to be right there on screen. And so I still have 2 copies. It's just one is on screen and one is held off stage. There's also a widget called a theater that is involved. I don't know how. Only been on the team like 5 months. But yeah, it's still all widgets. They're still all in the same tree at that point. And yeah, it's just some are rendered and some aren't. Anybody else have a question? Yeah, fire away.
Talk about plugin, right? So if I have a, maybe an app and you want to take some part of, whether it is impossible.
Sure. So you want to know a little bit more about how Flutter plugins work? Is that okay? Sure, absolutely. That's how I got started with Flutter. Let's take a look at that. So look at that, it's even in my search history. How is Facebook the first ad? Okay. Hey, we're supposed to compete with each other. That's how it's done. So let me zoom this in a little bit. So packages. Flutter, there are certain things you have to talk to the OS for. You have to talk to the platform for. There's no getting around that, right? So Flutter has a technology called platform channels, which if you've ever seen The Boring Show on YouTube, we did a little bit of to make a barometer app. There's a whole bunch of mistakes that I made doing that, so it's wonderful if you'd like to see things that'll cause you to question how I ever got hired. Not even kidding. But Flutter has a thing called platform channels, which can, and they have a technical diagram for it. I was looking for this. You can define a method channel for calling methods and an event channel for receiving events, either way. And so in your Dart code, you can say, I'm defining a method channel called this. I would like to call a method on it called this with these parameters, these are the arguments. Dart can take that, make a call into either iOS code, so native to native in that case if you're on iOS, or using the Java native interface to get into Java, and access code that you have written and included in your project in Java or iOS. And on the other end, there are some Java classes that you can extend and use to catch those calls and to take action on them. So for example, if I were to go back to Firebase AdMob, I'm going to look at the library real quick. So this is basically a Dart interface for AdMob on whichever platform you happen to be on. So it has classes for banners and interstitials. It also has rewarded video, which is the thing that I added way back to get on the team. And if you go down here, there's some code. Handle method. Where's my call? Initialize. There's a method in here to make a call. There we go. Invoke Boolean method. To basically make a call into platform code land. And with parameters that are coming from Dart. So you would say, start me a banner ad, here's my ad unit ID, and here's the size I want. Dart takes that, makes a call for you, and then in this plugin, you can see there's an Android and an iOS directory. So if we go into Android, for example, because I'm more comfortable with Android, if I go to Firebase AdMob plugin, this class implements an interface called method call handler, where it has a static method there called register with. That gets called to sort of wire everything up. And then in here, you can see where it's catching calls and then doing things on the platform side to actually make the Android interstitial ad object and then call methods on it based on the things that it's hearing from Dart. So you have to construct a little, we have Dart land and we have platform land. So you need to construct a little bridge for yourself. But other than that, there really isn't anything you can't do. It's platform code at that point. You can do most anything you want to do. And just to give you an idea of how many plugins already exist, these are just the ones that I think are being maintained by Flutter, the Flutter team. So URL launcher is something I use to launch URLs on the device. There's Firebase stuff. There's a lot of support for Firebase. Like I said, there's the AdMob plugin. And then there's a whole bunch that are made by the community as well. If I go to Pub, which is the Dart package manager, I should be able to go like this. In fact, we already saw. And so this is where I can find packages. And there's a little, I would encourage you to pay attention to this forum, which is pretty cool. It'll tell you a little bit about the project health for the plugin that you're looking at. But yeah, so in essence, you can have a little module like that has the bridge for you and the platform code, and you can generally just pop it into your project, and away you go.
But you cannot capture it as streams or so we have an existing Android app, and you guys like that. So can Flutter be part of that,
Sure. So basically, how do Flutter UI widgets and native UI components work together? So that's something the team is currently working on. And again, you can go into the pull requests and watch them working on it. It's something that's being worked on for maps, for example, and web views extensively. Right now, there are a few things you can do. If you have a complete activity that you would like to use, you can launch that activity from the Flutter code, and the new activity will pop over top of the one that's displaying Flutter, and you can interact with that, just a standard Android activity. And when that one gets popped, you're back in Flutter land. You can get data from, you can have passage of data both ways. We have some examples that will show how to do that. And so that's one way to do it. Having an Android view sort of mixed in with the Flutter widgets, because they're Flutter just renders onto a GL canvas. That's all it's doing. It paints every pixel itself. And so to integrate another native Android view is tricky. It's a complicated thing to do. Same for iOS, but it's something the team's working on right now. You can go into the Flutter source. I think it's Android view. Let's see if I can find this. Here we go. So there's a stateful widget for Android view. And I have not had time to mess with this, and it's still something that's in active development. But this is a widget designed to display a native view, paint it where it's supposed to be based on where it is in the widget tree, pass on input events and things like that. So this is something the team is working to make easier. There's also the question of whether you can mix a little bit of Flutter into an Android or iOS app. That is also something that's being worked on right now. I don't know if anybody saw the Alibaba video that was just released. The GDD China was night before last or last night. Last night, and that was when they announced release preview 2, and they also talked with Alibaba about doing that exact thing. They put a little bit of Flutter in an existing Android app, and were able to ship it to something like 50 million users. So, which is not a number I get to say much. It's wonderful. Who else has a question? Anything? Scott?
One last one. Back around November, I had asked about map support. And I was told back then that they had already requested it from the maps team. Apparently they were waiting on something, even back then. And still haven't seen anything. So I'm wondering if what we're just talking about is maybe they're attempting to do a workaround, or do we have a status on what's going on with map support?
Sure. I know map support is, I wasn't on the team in November. Sorry to give you a cop-out on that. So whatever discussion they were having, I was not party to it. I don't know if the maps team is, I don't know what they might or might not be doing. I do know where you can go to find out how maps is going. There is a plugin for it that they're working on right now. It is in the, that same packages repo that I was looking at before. There's an example in here. This has not been published because it's not done, but this is Google Maps. They're doing Android. I believe it's a little bit ahead of iOS. I have seen this running on someone else's device, but it's not published and finished yet.
This is not the one that's already out there doing the snapshots.
No, this is something more, as I understand it, this is something more sophisticated. And again, I haven't had time to dig into maps personally because we sort of start in on something when it's a little bit more finished than that to make an example and get it ready for launch. So again, take what I'm saying with a grain of salt. But it's something that we really want to have done in the near term, put it that way. It's an important thing for people. So. Anybody else?
Just to add to what you said, correct me if I'm wrong, the way you said plugin should work on Android, specifically you went down code and then through JNI back to Java. So the cost of backend code is just the cost of using JNI.
Marshalling data, and yes. Chinmay is the person on the SDK team that knows a lot about this. We haven't, one of the, we don't have a sample yet. It's on my list of things to do, to just stuff a whole bunch of data across method channel calls and just see how fast it is. But generally, yeah, you have to, the cost is just marshalling data from one side to another. And one of the things about Dart is it's single-threaded. So Dart is single-threaded, and even if you're talking about doing data in a background thread, you can spin up another one. It's called an isolate. There is no memory sharing between two isolates in Dart. So similar to the platform channels, if you want to move a bunch of data off to have it executed somewhere else, you are moving all of the data. There's no shared memory. There's no way for another isolate to call back into you to get access to your data without you copying it over. And the same is true of JNI calls as well, as I'm sure you know. No? Okay. Long ago, I used to do C#, and I had to platform invoke calls to C++. I don't know if anybody does that work. I was in Columbus when I was doing it. Good times. Anything else? Anything I didn't get into enough detail on?
What about build system? What does it typically use?
That is a very good question. The Flutter build system is run by, this is not something I'm really going to be able to answer, unfortunately. We don't have a build system in the way that Android has something like Gradle, where you can mess with it. You do have things known as builders and things like that. The build system is basically take the Dart code, and if you're making a release app, you ahead of time compile it into a shared native library, so .so or a .a if you're on iOS. Then you take that and you pop it into a runner application. So there's an Android directory here that's a full Android app. And that's a little shell that gets built, just like if you were using a game engine, you would have a native library that goes into a platform engine that then runs it. That is how Flutter is architected as well. So it would build the Dart code into a native library, and then that would go into a runner, and it builds using Xcode for iOS, and it builds using Gradle for Android. Yeah. Cool. Yeah, I think so.
Yeah, because our liaison needs this.
Oh, sure.
So we can keep talking, but we just have to do it outside.
Sorry.
No, that's all good. I want to thank everyone for coming. Thank Andrew very much.
I'm completely sincere when I say I thank you very much for allowing me to come out here and talk. This has been great.
Anytime you want to come back, man, let us know. We'll make that happen.
I'm gonna request it.
Yeah, do. So yeah, thank you all for coming. Like I said, next month we're doing Ohio Dev Fest. You can check out ohiodevfest.com for details. And then in November we're going to be doing the Flutter Study Jam. So if you like what you saw, come to that, and we'll do 3 weeks of running the Udacity course. And then Scott here had an announcement he would like to make.
Anyone who's looking for live help with Flutter? No, he's never heard of this.
This is new?
Hump Day Q&A. And it's on a Zoom account. You use zoom.us to get a live meeting. We do screen share. We can actually take over people's keyboards and mice. The interesting thing about it is when I first started the idea of this, it was like, okay, we're going to get together after work and help people with Flutter. And it's like, after work for who? We've got one guy in Tokyo, 2 more in India, 1 in Nigeria, 1 in Lebanon, 3 in Germany. So we start this at 0000 UTC and it runs for 24 hours. If it's Wednesday, 8 UTC, Hump Day Q&A is going on. Now, the easy way to find this, if you haven't seen it, you're going to want to see it, is the official announcement for 2.0, release 2.0. If you scroll to the very bottom of it, you'll see that there's stuff about the community, which is the Flutter community. And you'll also see that there is a weekly, what do they call it, a weekly meetup? Something like that?
There's a whole bunch of, there's a weekly hangout, a whole bunch of stuff.
We'll take you to our page on Flutter Media and help you right up. So it's right there in the official announcement.
Perfect. Yeah, thank you all. Like I said, we can continue chatting outside. We just need to let our friend go home.
But your coworker,
Oh yeah, that's great.
yeah, that's why I was emailing to answer your question. I said, I think someone from your team is coming to
What do you think there's a saying in English?
I just want to thank you for coming out.
I'm sorry I kept staring at you. You were exactly in the right place. And every time I looked up from my screen, there you were. So it's fine. That was awkward. I didn't mean for it to be so intimate for us. So states, one of the things I'm used to
And also, like I said, if you look at the announcement it's right there in the very bottom for resources. Yeah, 2.0 was just announced last night.
So there's this
Preview. Yeah, preview. But yeah, no, but if you go down to the bottom of the preview too, yeah, that's it. Yeah, there's
in order just to have access to the Teams model, that we have a dialogue.
this guy's great. It's great.
I guess
The way I look at it is,
it's in a different state.
you have a chance to restart everything all over again, knowing what you know.
Without trading this. So if your simple dialogue is 3 things long, you want to take
So
so
they,
3
and it's not saying anything bad about it.
15 hours to give the state, unless it was something fancy. But then if
We have all this.
which is the sense that we get the background of the period. If you're using like all your statements, so that's why one way that you're launching is value that can be used to set state in the screen that calls it. Yes. Okay. If I can see the code, I might come up with
Right.
it didn't. I mean, it's not that. But I will say this: are you on the Flutter group?
Yes, I think so.
This would be something that you can put in as someone will probably immediately see
It's on there.
It's like a point there are
Take care. You're welcome. Please see
Don't worry about it.
Andrew, I need to eat that.